Hello, good morning, students. So let's move on from what we did last time. So we are done till here, right? We learned about unit vectors. That is vectors whose magnitude is unit. Unit means 1. Vectors whose magnitude is unit are called unit vectors. So I cap magnitude is how much? Equal to 1. J cap magnitude is equal to 1, right? And I cap, J cap, they are called unit vectors. So let's move on. Find the displacement of an ant that moves 10 meters along the positive x-axis from the origin. So from here, if you move, let's say 10 meters along the positive x-axis, so you end up reaching here, right? So you have to find the displacement of the ant, 10 meters. Now see, 10 meter is simply the magnitude, but displacement is vector, right? So simply writing 10 meter will not be giving me displacement because that's just a scalar quantity, right? So I have to make it vector, and how do I make it vector? By multiplying it with direction, right? And what is the direction? Direction is I cap. So if I multiply with I cap, it becomes 10 meter I cap, and that entire thing is called P vector, which is the vector quantity, right? So P vector is equal to P into P cap, where P is the magnitude and P cap is the direction, and magnitude is, as you can see, 10 meters, and direction is I cap. So your P vector becomes 10 meter I cap, right? So that is a complete thing. That is how you should write it. Now let's do another question where the ant moved 7 meters, but this time along the positive y-axis from the origin, right? So like this. Now this is 7 meters, but that is only the magnitude. The direction is j cap, right? So your displacement becomes 7 meter j cap, right? So depending on the situation, you have to write down the displacement in each case. Right? So you can take this down. Okay, so let's go ahead. Angle between vectors. So let's say you have two vectors, A vector and B vector. So to find this angle between vectors, first we ought to bring the tails or heads of the vectors together. So we are going to learn how to find angle between vectors, right? So what is the first step? You have to bring the either the tails or head. Anything will work, right? You either bring the tails together or you bring the heads together. So here we have got the tails together. And the smaller of the two angle is considered as the angle between the vectors. So this is the smaller of the angle, right? The smaller angle, because which is the this is a smaller angle. This small angle, which is the big angle, if you see, I'll show you which is the big angle. So there are two angles formed. One is small angle and the other is big angle, and this is the big angle. Big angle and small angle. So angle between vector is which vector? Which angle? Smaller of the two angles is considered as the angle between the vectors, right? The smaller angle is the angle between the vectors, not the big one. So this is the angle between the vectors. So the tails should be together or the heads should be together, any one of them. And if they're already not together, we can still bring them together by performing. So what can we perform? If they're not together, if the tails are not together or heads are not together, what we have to perform? By performing parallel shifting. On any vector or any particular vector? On any vector. You have to perform parallel shifting on any vector. Right? If you perform parallel shifting on any vector, you can bring them together by performing parallel shifting. And parallel shifting, you know what is parallel shifting? Now in this case, heads are together, right? So which is the smaller angle? So can we find out the angle between vectors? Yes, because I told you either the we have to either bring tails or we have to bring the heads together, right? And in this case, already the heads are together. You see, heads are already together. So heads are together. So which is the angle between vectors? This is the angle between vectors, right? Angle between vectors is this angle. Let's go ahead. Can we shift any two vectors for parallel shifting? Can we shift any one of the vector and any one of the two vectors for parallel shifting? So here I told you to find this we ought to bring the tails and head together, and if they are already not together we can still bring them together by performing parallel shifting on which vector? Any vector or any particular vector? The answer was, as I told you, on any vector you can perform, right? So there are two vectors here and I want to find angle between vectors. And how do you find angle between vectors? By bringing the tail or head of the vectors together. How to bring tail or head together. So here what is together? Head and tail are together, right? tail and tail is not together. Head or head is not together. What is together? Head and tail is together. So what do we do to bring them together? What do we have to perform? As I said, we have to perform parallel shifting, right? We have to move things parallelly. So which vector should we move? Tell me, out of the two vectors, which vectors should we move? Let me draw the vector. So this is one of the vector and this is one of the vector, right? Which one shall we move? We can move any of the vectors, right? Let's move this vector. And we have to move it in such a way that, what is the condition? Remember the condition. The condition was either the tails or the head should be together, right? Which is not the case right now. You can see it's a very bad situation because we have a head and a tail together, and we can't accept that because we ought to have head and either head and head together or tail and tail together, right? And we have neither of the two situation right now. So this is not a good situation. So let's improve it. How can we improve it? Let's see. To improve it, what I will do is I will take one of the vectors, right? And I will shift it parallelly like this. Or I'll take one of this vector and I'll shift it parallelly like this. You see this parallel shifting? This is how we bring it. Now you can see that this tail and this tail are together or not? Both the tails are together, right? Tail and tail are together. That's what I wanted. I wanted tail and tail to be together. Now they are together. Did you guys understand what I did? I made sure that tail and tail are together because that was the primary condition to start with, right? I wanted tail and tail to be together. And what is the angle between vectors? If you see, this is beta. So how much will be this? This will be pi minus beta, this angle. And that is only the angle between vectors, right? Because the tails and tails are together, this angle is the small angle, and that is why it is the angle between the vectors. Now, why I am not taking this as the angle between vectors? This is not angle between vectors. Why? Because this is the big angle. And big angles big angles are not angle between vectors. Small angles are angle between vectors. Right? So it's very important to understand what are angle between vectors. Write it down. Next, what will be the angle between vectors here? Can you tell me? We have to do the same thing here also. We have to bring the head and tails, sorry, tails and tails together. Right now, what is the problem? You will see the problem is there is this head and there is this tail. Head and tail are together, so we can't find our angle. So I have to parallelly shift one of the vectors. And which vector will shift? Let's see. This is one vector. This is the vector, right? That we have to shift. And we have to shift in such a way that tails and tails come together, right? So what we can do to this vector, we can take it and we can shift it forward like this. Now the tails and tails are together, isn't it? This tail and this tail are together, right? And this angle will be what? This beta. So this will be pi minus beta. So what is the angle between vectors? Now you can see this is the angle between vectors. What about this angle? Will we take this angle as angle between vectors? This angle? No, this is the big angle, right? The big angle is not the angle between vectors, right? It's not an angle between vectors. Small small angle is, right? So this is a small angle and it is angle between vectors. Let's say there are two vectors. So angle between these are parallel vectors, right? Parallel vector is 0. Then we have this vector and this vector. An angle between their anti-parallel vectors, right? Angle between anti-parallel vector is 180 degree. Their anti-parallel vectors, angle between them is 180 degree. Right? Now, angle between two vectors is, they are also parallel vectors, right? The angle will again be 0. Now, in the given figure, angle between A and B is how much? C and D is how much? That we have to find out. So, which option is correct? Let's find out. So, angle between A and B, A vector and B vector, what is the angle between them? For that, we have to shift the vectors A parallelly. Why? Because right now the head and the tail are together, right? So we can't allow that because we need the tail and tail together, or head and head together. So this is the A vector and we shift it parallelly. Okay. So how much is this angle? This 110. So this should be 180 minus 110, which is 70. But they are saying it is 110. That's wrong. Next is angle between C and D. So for C and D, C vector and D vector, angle is how much? See, head and head are already together. So what is the angle between vector? 120 degree is the angle between vector, but they are saying it's 60. That's also wrong. Then let us find the angle between B and C. For that, I have to do parallel shifting. I have to bring tails and tails together. Now you can see tails and tails are together. So B vector has shifted here and the tails and tails are together. Right? Tail and tail are together. The B vector is shifted here. So how much is this angle? 180 minus 70, which is equal to 110. Right? That's the correct answer. C option. Take it on. Right. So let's go ahead. Multiplication of vector by a positive number. So let us say that we have this a vector here, right? And we want to draw two a vector. That means you have to draw twice, two times of this vector, right? That's a vector. I want to draw two a vectors. So how can I do that? 2a means I simply have to double it. So multiplying a vector with a positive number changes the magnitude of the vector by the same factor. Means if I want it 2a, I have to multiply it by 2 times. Means I have to double it. And am I changing the direction? The answer is without changing. Without changing its direction. Okay. What about 3a? 3a will be 3 times. Without changing the direction. And what about a by 2? A by 2 will be, as it says, half of that vector. So in all the cases, without changing the direction, that is important. You know? Only the factor by which you multiply that changes. Take it down. Next, multiplication of vector by a negative number. So multiplying a vector by -1, what will it do to the vector? Let's say you have a vector here and you want to multiply it with -1 and you want to make minus a vector. So if a vector is in this direction, minus a vector will be in this direction. So multiplying a vector by -1, what does it do to the direction? Inverts. Inverts its direction. Does it change the magnitude? Without. Without changing its magnitude. Now, then what about -2a? This a vector, what will be -2a vector, tell me? A vector is this, -2a vector will be negative of this, means opposite direction. But since it's 2 times, it will be changing the direction, but making it how many times? 2 times. Similarly, what about multiplying with -1 by 2? It will also change the direction, but make it half this time. Minus a by 2. Next, multiplication of vector by 0. When you multiply a vector with 0, what you get is a something called null vector, right? It's represented by 0 with a bar. So, and it is basically a point, right? Represented by a dot, just a dot, that's it. Dot, or you can say 0 bar. Does it have any direction? No, a dot has got no direction, right? No direction. So if you multiply this by 0, you get a dot. That's it. Nothing else. Right? Next, arbitrary number minus 2 is multiplied to a vector, then which of them is true? Now select which of them will be true. We know minus means there's a negative term here, so it is going to change the direction. The magnitude, and it's 2 times, right? So it will double the length. So magnitude of the vector will be double and direction will be opposite. That's absolutely correct. That's what you've studied, right? So this is straightforward. I think there is nothing much here. You multiply with minus 2, minus will change the direction, means it will make it opposite, and 2 times means it will make it double the size, right? Then now we will come to vector addition. So let us see what is vector addition. So why are we going to study vector addition? The reason is, you see, we know, I'll not start the topic right now. I'll just tell you why are we going to study vector addition. You know, because if I start the topic, I can't complete it. It's a very big topic. There are a lot of things, and I want to do it in a one particular class itself. If I start now, I won't be able to finish it. So what I'll be doing is, I'll just be telling you what is vector addition, why do we need vector addition, right? So let's see, why do we need vector addition at the first place? You know, the heading is why vector addition. Let's see why vector addition, right? Why are we adding vectors? What is this all business of adding vectors? So till now, if you remember, we know how to add 2 and 3, right? What is 2 and 3? 5. We know that. This is what type of addition, guys? It is scalar addition or vector addition? These are scalar quantities, right? Scalar. So similarly, 2 meter plus 3 meters, that also you know is equal to, sorry, 2 meter plus 3 meter is equal to 5 meters. Now, similarly, 3 meter per second plus 4 meter per second is equal to 7 meter per second, right? So these are all what type of additions? Scalar addition, right? Then tomorrow we'll see what is vector addition and why do we need these laws. What is the reason of having these laws, right? That we'll see tomorrow.